Hello all. Today we will discuss Exchange 2016 Preferred Architecture. The video will have the important technical details discussed in a quick and concise manner. First, let's discuss namespace design for the client access traffic. Microsoft recommended approach is to deploy Unbound namespace. It is single exchange namespace per client protocol for the site resilient data center pair. What is site resilient data center pair has been discussed later in this video. Let's see how the Unbound namespace looks like. As shown in this diagram, we are using the same namespace for both sites named West and East. Irrespective of the location, the users and mailboxes will use the same namespace to access the client access services. For example, autodiscover.condiso.com for autodiscover and mail.condiso.com for web clients. Each Exchange namespace is load balanced across both data centers with a Layer 7 load balancer with no session affinity. Traffic is equally distributed across the data centers via Robin DNS, DNS, or other similar solutions. Simple and easy to manage solution is to leverage Robin DNS. When using Robin DNS, one caution is to assign a low TTL value for any DNS record associated with Exchange. In the event of a full data center outage, it allows to quickly update the DNS records. It is also important to mention that DNS allows to deploy Unbound namespace even when network links between the data centers are costly or with high round-trip network latency. DNS allows to have users directed to the closest data center based on their client's IP address. As shown in the previous diagram, important consideration is that data center affinity is needed for the Office Online server farms. So specifically for the Office Online server farms, the namespace is deployed per data center with a Layer 7 load balancer maintaining session affinity via cookie-based persistence. So the Office Online server farms will have Unbound namespace like whoswest.condiso.com and whoseast.condiso.com. Let's now move on to site resilient data center pair design. To achieve a highly available and site resilient architecture, the data centers must be well connected with low round-trip network latency to avoid replication and client experience issues. It is recommended that the data centers are connected via redundant network paths supplied by different carriers. It is recommended that each data center is in its own AD site because transport site resilience via shadow redundancy and safety net can only be achieved when the DAG members are located in more than one AD site. Let's discuss server design now. Preferred architecture is to use physical servers with locally attached storage as virtualization comes with a slight performance penalty. Virtualization also adds an additional layer of management and complexity. Commodity server platforms are recommended. Recommendation remains to scale out rather than up. Deploying a larger number of servers with slightly less resources with reasonable number of mailboxes per server is recommended, rather than a smaller number of very dense servers using maximum resources and populated with large number of mailboxes. Thus the impact of any outage and risk of system bottlenecks is reduced. For storage design, what is preferred is single RAID 1 disk pair for the operating system, Exchange binaries, protocol and client logs and a transport database. The remaining storage is configured as JBOD. All disks housing Exchange data are formatted with REFS, with integrity disabled. It is recommended to encrypt each disk with BitLocker. Let's now move on to DAG design. It is not recommended to stretch a DAG across more than 2 data centers. It is preferred to have active copies distributed equally across all servers in the DAG. It is preferred that each data center is symmetrical with an equal number of DAG members in it, having a witness server for core maintenance. An 8-member DAG is preferred. A new DAG should only be created when the existing DAG has scalability concerns. For a DAG network, single and non-teamed network interface for both client connectivity and data replication is preferred. Recommendation is to deploy the witness server in a location isolated from network failures in the data center pair. It enables automatic failover in case of a data center level failure. If there is no third location, the witness server can be placed in Azure or in the data center where the majority of the users are physically located. Let's discuss the data resiliency now. In the preferred architecture, database copies are distributed across the site-resilient data center pair to protect data even from a data center failure. It is preferred that each database has 4 copies with 2 copies in each data center. The 4th copy is configured as a lagged copy. It is configured with 7-day replay lag time with Replay Lag Manager enabled to provide dynamic log file playdown after loss of non-lagged copies. To protect against accidental or malicious item deletion, single item recovery, in-place hold, or deleted item retention can be used. Due to these awesome features, traditional backups are unnecessary. Lastly, it is preferred to deploy an Office Online server farm with at least 2 nodes in each data center. Mailbox servers should be configured to rely on the local Office Online server farm in their data center to ensure the lowest possible latency. Thanks for watching. Please do subscribe to the channel to get notified on future videos.